Dear students, we are discussing about the electrolysis in this session. So that's why, first of all, what is meant by electrolysis? Electrolysis means the decomposition of a electrolyte at the electrode by passing of electricity is known as the electrolysis. Decomposition of electrolyte at the electrodes by passing of electricity. So that's why here we are writing that is decomposition of a electrolyte by passing of a decomposition of electrolyte at the electrodes by passing of electricity known as a electrolysis. So here electrolysis, the device used for electrolysis. That's why which device is used. Device used for electrolysis. Used for electrolysis is known as electrolytic cell. Electrolytic cell. So yeah, that's why we are taking the what is meant by electrolytic cell. That's why we are discussing about electrolysis of molten NaCl as an example. That's why here discussing about the electrolysis of molten NaCl. So here electrolysis of molten NaCl we are discussing here. So in this case, electrolysis of molten NaCl. So molten NaCl we are taking molten NaCl. So that's why here we are using a device that is here as beaker is taken or vessel is taken, which is filled with a molten sodium chloride, molten NaCl. It is arranged or dipped with two electrodes, okay, which are connected with the battery. This electrode is acting as a anode. This electrode acting as a cathode. Here, anode is connected with the positive terminal of the battery. That's why the sign of the anode is positive. Cathode is connected with the negative sign, negative terminal of the battery. That's why it is having negative sign. Then anode and cathode are taken. But these two are acting as the electrodes. That's why, first of all, we have to know electrodes. Electrodes are basically two types. One is here inert electrode and active electrode. What is meant by inert electrode? Inert electrode means here it is the electrode which does not involve in the reaction, does not involve in a reaction. So does not involve in reaction at the electrodes during the electrolysis. But we can take the active electrode. Active electrodes involves in the reaction at the during the electrolysis here. That's why we can take the example platinum electrode are the best example for the inert electrode, and nickel is the best example for the active electrode here. So that's why we can take here nickel or silver. Okay, silver is also active electrode. Okay, this is here the example for the, or we can take the copper. Copper is also active electrode. So this is the electrode. But in this case, how the reaction is given at the electrodes we have to. So that's why here at the anode, which reaction is given. Generally at anode, that's why here, first of all, when current is passed, NaCl converts into which one here? Na plus and Cl minus. NaCl converts into Na plus and Cl minus. That's why here we are taking that is But NaCl is acting as a electrolyte. But which electrolyte is taken? Molten electrolyte means molten NaCl. But we'll get the doubt, that is, it is solid NaCl, solid NaCl conduct the electricity or not? Conduct the electricity. But solid NaCl does not conduct the electricity. Does not conduct the electricity. Mean does not accept the passing of current through it. Why it is here? In solid NaCl, Na plus Cl minus ions have the strong electrostatic force of attractions. Okay, that's why here they are having strong electrostatic attractions here. That is strong electrostatic force of attractions. Due to that, that does not accept the passing of current through them. But you will get the doubt, that is here molten or aqueous NaCl. Molten or aqueous NaCl. So molten or aqueous NaCl, they are having the weak electrostatic force of attractions here. Having weak electrostatic force of attractions. That's why they are giving the electrolysis. Electrostatic force of attractions here. So that's why they are acting as a electrolyte here. That's why they are conducting the electricity through them. But how the reactions are given at the electrode, we have to discuss in this case. That's why here, first of all, at anode, what reaction is given? At anode, what reaction? Generally, anion moves toward the anode side. Anion moves towards anode side in any electrolysis. So we are discussing the example for the electrolysis of general. Okay, general example it is here. We can take everywhere in every electrolysis process, anion moves towards anode, involves in the oxidation at the electrode at anode only, moves towards anode and involves in a oxidation. That's why here, remember, we are writing, that is here simple code of this one, that is anion moves toward the anode side, involves in oxidation. Remember this one, anion moves toward the anode side, involves in oxidation. But what is here the oxidation of this one here? That's why in this case, what is the anion? Cl minus is anion. Anion of Cl minus moving toward the anode side, losing the electrons converting into Cl2 gas. So that's why here Cl2 gas is liberated by involving of how many moles of ions? 2 Cl minus ions, producing 1 mole of Cl2 gas. But remember, Cl2 gas is nothing but what here it is? Non-metal. Cl2 gas is here the non-metal. That's why here non-metals are giving here which one? Non-metals are produced at the anode. Remember the point here. Non-metals are generally electronegative elements. Okay, that's why here generally at anode, electronegative elements are liberated. More electronegative elements are liberated at the anode here. Then here we are discussing another point about this one here. That's why I'm erasing some of the points from this one here. So that is here at cathode, what reaction takes place? At cathode, cation. That's why we are writing same statement here. Cation moves towards cathode, moves towards cathode side here, moves towards cathode. Involves in which reaction? Cathode involves in a reduction. That's why here involves in a reduction reaction. So involves in reduction. Reduction means what here it is? Gaining of electron. Oxidation means something but what here? Loss of electron. That's why in every electrolysis, At anode, loss of electrons is given. At cathode, gaining of electrons is given here. It is. Na plus gains electron converting into sodium solid. Okay, that's why here. The how many moles of electrons are released by 2Cl minus? 2 moles of electron. So those 2 moles of electrons are gained by the 2 moles of Na plus ions, converting into 2 moles of sodium solid. Then if you add, and before that, this reaction is nothing but what here it is, reduction reaction because gaining of electron. So finally, sodium solid is deposited at the cathode and chlorine gas is liberated at the anode. Sodium is nothing but what here it is, metal. That's why we can give a general point. Metals can be liberated or deposited at the cathode generally. At the cathode, metals can be deposited. And at the cathode, hydrogen gas also liberated in general other examples. In other examples here, hydrogen gas is liberated at the cathode. Hydrogen gas is liberated means that is liberated at the cathode only. And metals are deposited means at the cathode only occurs. And this is here the point. But if you add these two reactions, we are getting the overall reaction of this one here. 2 Na plus ions, 2 Cl minus ions, and converting into 2 moles of sodium solid and 1 mole of chlorine gas here. 1 mole of chlorine gas here. And this is here the which one? 2 moles of Na plus and 2 moles of Cl minus. Finally, 2 moles of sodium solid, 1 mole of chlorine gas is liberated. But you can remember one word that is here. Cation moves toward the cathode side, involves in which reaction? Here we told reduction. Remember CCr and AAO. So cation moves toward the cathode side, involves in reduction. This is electrolysis of molten NaCl in presence of inert electron. But in electrolysis here, electrical energy converts into chemical energy. That means by passing of electricity only the reactions are going at the electrodes. That's why here the electrical energy converts into chemical energy in all electrolytic cells. In all electrolytic cells here. Then if we see the electrolysis of aqueous NaCl, electrolysis of aqueous NaCl. So aqueous NaCl means what here it is? NaCl first of all dissolved in water and arranging the same process here it is. Arranging the same process. That's why we are taking aqueous NaCl. Then in this one, 2 electrodes are arranged here it is. Again, we are arranging the same platinum electrode. This is also platinum inert electrode. It is acting as the anode, which is positive side, acting as the cathode, which is here known as the cathode here, which is having negative side. But same method here, first of all, NaCl converts into which one? Na plus and Cl minus here. But we should take this as aqueous, means they are present in dissolved state in the form of ions in water. And then this is called nothing but what here? Ionization. When current is passed, initially ionization takes place. But we can take that is here. In this one, water also present. But water also giving which ions here it is? H plus ion and OH minus ions. Okay, that's why here Na plus H plus ions are given in this case here. But 2 types of cation, 2 types of anions are present in the solution. But which cation, which anion involves in the reaction at the electrode, we have to know. That's why here 2 cations are there, 2 anions. In last example, 1 cation, 1 anion is present. That's why they are involved in the reaction. But in this case, how many cations are there? 2 different cations, 2 different anions. That's why which is involving the reaction at anode, which is involving the reaction at a cathode, we have to know. Same process here it is. Cation is here, then anion. Anion means what? 2 different anions, Cl minus and OH minus. That's why here in these two, Cl minus is involving in the reaction not the OH minus here. Cl minus involving in the reaction, not the OH minus. But why it is, we have to know. And then here it is Cl2 gas is liberated by loss of electron. But the same method here, it is nothing but what? Oxidation. But cation here it is. In these two different cations are there, Na plus and H plus cations are there. Na plus and H plus. In these two, H plus involving in the reaction at the cathode and converting into which one here it is H2 gas. That's why gaining of electrons is nothing but what here it is reduction. Gaining of electrons is nothing but what here it is a reduction. So this is here the gaining of electrons. So finally, what we can say here it is gaining of electrons, nothing but reduction. But you have to discuss at anode Cl2 gas is liberated, at cathode H2 gas is liberated. But two different cation, two different anions are there. This is explained based on the discharge potential theory. Okay, that's why we have to know discharge potential theory. Simply we can know here dP, okay, discharge potential theory. According to this theory, the ion which is having the highest discharge potential that involves in that does not involve in the reaction. The ion which is having the lowest discharge potential that involves in the reaction at the electrode. That's why here for anions, I am writing here the dP discharge potential value order of the discharge potential of different anions I am taking here. So that is here first of all F minus, then SO4 minus 2, then NO3 minus, then OH minus, Cl minus, Br minus, and I minus here. So in the above solution, how many ions are there? Cl minus and OH minus. So these two ions are present in the solution. But which is having the lowest dP value? Cl minus. That's why Cl minus only involves in the reaction, not OH minus. That's why which is having the lowest dP value that involves in the reaction at the electrode. Other one does not involve, that is present in the solution as it is ionic form. But for cations here it is. That's why here for the cations. So what is the dP order of this one? Then in this case we can take Li plus. Next one we can take K plus and Na plus. Next one Ca plus 2, Mg plus 2, Al plus 3, Al plus 3, Mn plus 2, Zn plus 2. So that's why here Mn plus 2 and Zn plus 2. And next one Cr plus 3, Cr plus 3, Fe plus 2. Next one H plus and Cu plus 2, Hg plus, and next one here Ag plus and Au plus 3. So this is here the which one? Order of dP value order of different cations. So which is having the highest dP that does not involve in the reaction, which is having the lowest dP that involves in the reaction at the electrode. In the above example, what we can take here, Na plus H plus, which is having the lowest dP H plus than with comparing the Na plus. That's why Na plus is not involving, H plus is involving in the reaction at the electrode. So that's why we should follow these orders for the electrolysis of solutions which are having more than one type of cations and more than one type of anions here. So okay, this is here the electrolysis concept of aqueous NaCl and the molten NaCl. Based on this concept, we'll discuss the questions by next session. Thank you.